Kia ora Year 11 and 12. This is the first part of question 1 of last year's calculus paper. So as usual I've split this into the achieved and merit bits. The second video will have the merit and an excellence question for question 1. As usual, try and do the questions before I go through them. Okay, so question 1, we've got a function given by this thing here, and we've got to find the gradient of the graph of the function when x equals 2. So a nice easy warm-up question. So we're going to differentiate and we get 12x squared minus 14x plus 2. We're looking for that gradient where x equals 2, so we substitute in 2 for x and we get 12 times 4 minus 28 plus 2. And that equals 22. So that's a little achieved code. Right, on to the next one. Okay, this is a slightly funny question. And the assessment schedule's got a couple of ways to do it, but I'll show you how I've gone about it. So we've given a line. This line here is a tangent to the graph of this function. So it's a show that question. So we're asked to use calculus to show that the line is a tangent to the curve and that the point where this tangent touches the curve is this one here. So I think the most straightforward way to go about this is to say, well, let's get the equation for the gradient of the tangent anywhere, and then we're going to show that when x is equal to 0.5 we end up with this line. So when we're working with the equation of a straight line, one thing that's really useful to have is the point gradient equation, and we've used that over and over in class. If you're watching and you've done the coordinate geometry standard, that will be really familiar to you as well. Anyway, what am I going to do? Well, I'll differentiate f and I get 6x minus 2. So that's my gradient function for anything. So at x equals 0.5, f dash of 0.5 is equal to, so 6 times 0.5, 3 minus 2, which is 1. So the slope of the gradient will be 1. And now we're going to use the point that we've been given, 0.5 and 3.75, to find the equation of the tangent. And I'll do that on a new slide. Okay, so we've got y minus y1 equals m times x minus x1. So y minus 3.75 is equal to 1 times x minus 0.5. Okay, and again that's because I'm using this point here, which is on the parabola. Okay, and at the very end I'm going to check that that really is on the parabola. So y is equal to x minus 0.5 plus 3.75, which is x plus 3.25. This is the line given. But just checking, making sure that that point is on the line. So let's substitute in f of 0.5 back into the original function, and what do we get? And let's just check. So it's 3 times 0.5 squared, so that's 3/4, minus 1, 2 times 0.5, plus 4, so that gives me 3.75 as told, or something like that. Okay, so that's that one. So it's quite a clunky question. It's not that hard. The schedule's got another way that they showed, so you can have a look at that. But I think it's easiest just to figure out what's the tangent, equation of the tangent for that equation, and show that it's what you were given. Okay, so this one here is also a merit question. We're given a function, and we're told that it's got a minimum turning point when x equals 1, and we're asked to figure out the coordinates of the maximum turning point. So let's look at what we know. Well, we know that the gradient function is 6x squared plus 2kx. And if it's got a turning point at x equals 1, that means that f dash of 1 is equal to 0, right? Because at a turning point the gradient is 0. So 6 times 1 squared plus 2k times 1 is equal to 0. 6 plus 2k equals 0. K is equal to negative 3. Okay, now that means that I can now put k back into here, or I could put it back into here. Either will work. Slightly less work to put it back into here. So we'll do that first on the next slide. Okay, so we had this before. F dash of x is equal to 6x squared plus 2kx. But now we know that k is equal to negative 3. So f dash of x is equal to 6x squared minus 6x, which means we can set that equal to 0 to find, we're going to solve for f dash of x equals 0, and we're going to have 6x times x minus 1 equals 0, x equals 1, or x equals 0. So this is the one we're going to work with. At x equals 0, what's the y value? F of 0 is equal to 2 times 0 cubed minus 3 times 0 squared plus 5. Right, so notice I've sneaked in there my k value. Right, because we had f of x is 2x cubed plus kx squared plus 5. Right, that's what we started out with. But now we know k, so that can come in here. Anyway, it doesn't matter because it's being times by 0, so we get the point is 0 and 5. But we haven't yet shown that that's a maximum. Okay? Oh, actually that's all we had to do. So we didn't have to check that it was a maximum. But to do that would be very, very easy. We can do that using our second derivative test. So even though that's not on the question, I'll do that just for a little bit of revision. All right. So you don't have to use the second derivative test. You can do it with a table of values, checking the sign of the gradient. But the second derivative test is just so easy. So we get 12x minus 6. Now we evaluate that at our turning point. So we're looking at what happens when x is 0 and it's negative 6. Now that's negative, so we have found a local maximum. Okay, and remember what's going on there is that that is all about the shape of the graph. Okay, so we've found a local maximum. This is not an accurate graph of that function, but just in general, what are we doing? Well, we're looking, we're looking around here, and we're saying the second derivative here is negative. Okay, right, that's all for now. Make sure that you go over any questions you had trouble with on your own after you've watched the video. Thanks for watching.